the truth values of data frame is ambiguous. So DF only we need to join into that, no? So BTC USD. Yeah. So I need to check the length over here. Yes. Now it is fine. Okay, now I should check on main DF. So this is main DF now. So now you can see that we have all the columns from all the files. Now, if there are any kind of missing values or so, we need to go for the data pre-processing part. So main, so PRE, is the pre-processing. So main underscore DF dot FILLNA fill NA. So I'm doing forward filling here. Whatever value is missing, so I will just fill from the previous column. I'll fill. Okay. So method is equal to fill forward filling I'm doing, and then I'll do in PLACE place is equal to TRUE true, so that it becomes. So I have filled all the values. Now by any chance, if there are any kind of still any values present, so I will just drop them. So main df dot drop na. So I'll just drop them even if still some values are there which are not okay. So although there are no, but just to be double sure, I'll drop the na values. Na are missing values. I'll be dropping them. Okay. So now we have the data set ready. Now, now we will have to get a sequence length. Okay, a sequence length for how long the preceding sequence. This length we'll have to define. So I will name it as SEQ sequence underscore len sequence length, and I'll give the value as 60. So sequence length of 60 we'll be using. Okay. And second is how much do we want to predict in the future, right? So here I'll use 3 as a number. Okay, so for 3 next values we will be making the prediction. So FUTURE future, PRIOD period, PREDICT predict. So I'm using 3. Okay, and then basically which ratio do we want to work for? Okay, so as of now we will be working for RATIO ratio to PREDICT predict. So ratio to predict we will be using here is LTC USD. So LTC USD will be selecting. Okay, so this is what we will be using. Okay, now let's basically have a classification. Okay, function. See. Okay, so we'll create a classification function def CLASSIFI def classify, and here we will put current and FUTURE future. So current and future, and here if FLOAT float FUTURE future is greater than FLOAT float CURRENT current, then RETURN return 1. Okay, so let me just change it, float. So if float future is greater than float current, then return 1, else you can understand return 0. Return 0, right? So what it is doing, if the value for future is greater than value for current, then return 1. So the 1 and 0 will help us to understand, okay, whether the future value is greater or less. That is basically help us. Okay, fine. So this is going to tell us that if the uh, return value is 1, then buy, else, okay, if the return value is 0, else sell. Okay, that is something. So this is simple function to tell us if return is 1, that means future value is going to be higher. If it is going to be higher, you should buy now so that you can gain some profits. And future value, if it is going to be lower, then don't buy now. And that basically will lead to loss. Okay, so that is something is a simple meaning of this particular function. Now, so now let us move ahead. Let's write main underscore df, and here future is a new column is equal to, we'll have main underscore df, and here we will have ratio underscore to underscore predict predict. So ratio to predict. Okay, so from here I'm taking LTC USD I have taken as of now. So ratio to predict underscore CLOSE close. Okay, so we'll look at the close price of that, right? And dot shift, and here future period predict. This way. So here what we are doing, okay. So so here you can see that now main underscore df. So look at this. Here you can see this future. Okay. So how you are getting this future? You are getting it for this one LTC USD. So look at this LTC USD. Okay. So it will bring this value. You can see 96.38. It is bringing it here. Okay. Now 96.51. It is bringing it here. So you have the old value and you have the future value. Correct. So from the known data, we have just done a shifting so that we can get the values from future. Okay, and 3 steps ahead value we are taking. So today we are taking the value of, then after taking the 3 next steps. Okay, so 96.38 is the value coming from 3 next steps. You can see here. That is what we are taking. Okay. So again, it is simple. Let's say we have 100 days data, so we can get the values. Okay, today I can get the next third day value. Okay, that is how we have taken the future value. And you can see that these last 3 become NA, because last 3 values we don't have, therefore they become NA, right? Now, let me have. So what we will do is, now because we have got the future value, okay, because we have got the future value, now I can get the target values with the help of the function, that is def classify, with the help of that. So main underscore df, and here I'll put target target, a new column I'll be adding, and here I'll have list. Okay, this is just for transforming the data into a list data type I'm using. And then map function I'll use map. I'll pass CLASSIFI classify function, and I'll be passing main underscore df. Okay, and I'll be passing the column which is RATIO ratio underscore to underscore PREDICT, ratio to predict. This column I'll pass here, and let me close the bracket, underscore CLOSE close. Okay, so this column I'm passing, and then second column I'm passing as, so this is the end of, so end of this particular data frame column, and then again main underscore df, I'll be passing the second column as future, only future, FU, TURE. So two values we are passing, right? Two values we are passing, and this becomes the target. Now again main underscore df, let me show you. So we will have a target value which is 0 and 1. So here you can see. So this target value 0 and 1, what is it? This target value 0 and 1 is telling us, okay, yeah. So this target value 0 and 1 is telling us whether I should buy or not. Correct. You can see that it is telling me whether I should go ahead, buy or not. The target value is telling me. Okay, fine. Fine. So this is the whole data set got prepared. Okay. And with the existing data set, with existing knowledge, we have done this particular part. And now what we will do is, so this data is prepared the way we actually wanted. This data is prepared now. Now what further we should do is, now we have here some NA values also. And for them we have got the result as 0 0. Okay, that's fine. Yeah, so we have got the result as 0 0. That's fine. So let me get the data into another variable. I'll create a variable as times, and name underscore df dot index dot values. Yeah, values. Let me see this, and let me display times. So this is sorted data, okay, into times, index wise sorted, and let me get the last 5 points also. So last and underscore 5 points PCT. Okay. In same thing I'll do SORTED sorted, and then I will use main underscore df, main df, and dot index dot values, values values, and here I'll just do multiply by minus int int, and here 0.5 0.05 into length, length of the whole of the data, which is times. So from there we will get, okay, last underscore 5 PCT. So here we should get last 5% of the data. Okay, so which is giving me only one record. So 0.05, okay, and length into times we are doing. Okay, so it's giving me 22100 this data. No worries, let's do it. So now we will create a validation data frame. So validation, let's quickly create it. Validation underscore main underscore df. So this is validation data frame we are creating, and from main df, main underscore df, we will have it main main underscore df dot index, which is greater than the last underscore 5 PCT, so which is greater than that, so that we will store, and then we will have main underscore df is equal to again main df. So we will have data which is where, yeah, so where main underscore df dot index is less than last underscore 5 PCT. So we have divided the data into validation and yeah, so something got yeah, this one, let me remove that. Yes, so we have divided the data into validation main df and main df. Okay, this is how we have divided the data. And after that, this much is done. Now let's quickly do. Okay, so we have divided. Now we will use sklearn pre-processing here. So let's use that from sklearn dot pre-processing. So from sklearn dot pre-processing, so we just need to import pre-processing only. So let me do from sklearn import pre-processing. Yeah, and then let's create a function def, and this function is to process pre-process the data frame. So pre-process df, where we'll pass the data frame here, and the first thing we'll do is df is equal to df dot drop drop. Okay, so what we will drop? We will drop future. Okay, so now wherever future is 1, we will drop that. Okay, and this is one thing. Second is, after that what we are doing is for call in df dot columns. Okay, so when if call not equal to target, target, then we need to normalize them. Okay, if the column is not the target column, then df call, okay, that call needs to is equal to df call and dot. So we have yeah, so we will use pct change pct underscore. So pct underscore. So I hope this function is available. So change. So this function is used for normalizing the currencies. Okay, so that's why I'm directly using this function. And let me see, if that doesn't work out, I'll have to work in a different way. And df dot drop na. So na needs to be dropped, and in place is equal to true. In place equal to true. And then after that, let's do df of that particular call. Okay, df of that particular column is equal to pre-processing. We just imported that pre-processing dot scale scale. We'll use scale, where we'll pass the same df call dot values. We'll pass the values over here. So I think we are good till this point. And now yes, still if there are any kind of drop values, we'll drop them. In place equal to true. Let me execute this. Yeah, so yeah, we have executed this. And so now let's create our sequential data now. So we have done a bit of pre-processing here. Okay, and we will use this pre-process df if required. Now normalized and scaling up is done. Now let's create actual sequences. Okay, so for creating actual sequences, we have sequential quentil sequential underscore data. So initially we will have empty, and then yeah, then we will have prev days previous days is equal to here dq, and here we will put max length, max length. So max length we will take as seq. We have taken sequence length, and that variable we are using here, sequence length variable. So yes, now for in df.values values. Okay, so in df.values. Now prev previous underscore days days. So it's days only, right? Yeah, previous days dot append append. So previous days dot append. So here we will be append as a list n for n in I. So I has got the values I colon -1. So we will store everything. -1 means the target value we will leave. Okay. So here except target store all. Okay, this is what we will do. If length of the previous days, okay, if it is equal to seq underscore len. So if it is equal to this, okay, that means we had in seq we had 60 sequences, I think. So 60 sequences we had planned. There is it. Yeah, 60. So if it is that, okay, then what to do? SENTIL sequential underscore data dot append append, we will be appending np dot array array. So we will put we'll transform all this into np array. Okay, numpy array. So previous days and yeah, here and then I of -1 -1. Okay, so this all needs to be in a single list. Okay, fine. That's it. So np I need to define. So let me just here import import and umpy numpy as np. Okay, I think we are good to go. And yeah, so we'll just do the shuffling at the end, and that we will do out of the for loop. So random random, we'll use random. Yeah. So random dot shuffle shuffle and sequen sequential data we'll shuffle. So sequential data. Yes. So we are done with this, and yeah. So let's write the last pieces of code now. Okay. Yeah, this much we have done. Fine. So random dot shuffle, it shuffled the sequential data. That is what we have done. So let me now create the model and execute it. So for the model, what I would require is, let's import time this time. Epochs we will have. So epochs we'll keep yeah, so 10. So 10 would be quite a big number, but I'm keeping it as 10. So BATCH batch size 64 I have kept, and yeah, so then it got reconnected. Then next is we yeah, so we are working on one particular sequence. So let me just give a unique name for the model, okay, for each sequence, and that I'll store in name. So name is equal to, so here we'll use string formatting, and so we have seq underscore len. Yeah, so this we will use 10 dash seq. Okay, then we have next as future period predict. Yes, this we will use. And then PRED bread. And after that, yeah, then I will have int. We'll convert time time. So time. We'll convert that into integer. So I closed one bracket, second bracket, and then this one I need to close. Yes. So yeah, then let's import certain libraries. Import tensor. Quickly, let me import TensorFlow. So TensorFlow as TF I'm importing. Then second one is from TNSORF TensorFlow dot KRAS dot MODELS models. Import sequential and control Z sequential. Then layers. Let's import layers from TNSOR TensorFlow dot keras dot layers. Import. So we need a dense layer. We need a dropout layer. We need LSTM layer. Then so we will require certain more. Let me just import them if we'll be able to use them. CUD and then LSTM. So already we don't have CUDA, but I'm importing them. Then we need BATCH batch normalization. Okay, so these are the layers we have imported, and let's import the tensor board and model checkpoint for callbacks. So from TensorFlow dot keras dot cll callbacks backs callbacks import tnsor tensor board and from tnsor tensorflow dot keras dot cll callbacks and import we will have model model checkpoint. Okay, so let me just see. For something it is giving it is CUDNN LSTM. Yeah, LSTM, it's right, no? Let me just remove this one. Okay, so yeah, with these we'll run. Okay, yeah, they are imported. Let me create the model now. MODEL model is equal to SEQUENTIL sequential, and let me add the layers. MODEL model dot add, and here let me add the layers. So actually I wanted to add the layer that is so I will just add LSTM here. Okay, let me once again load here CU. Okay, yeah, so that is not available, no worries. So I'll have to go with the LSTM layer only. So let me add LSTM layer. So LSTM. Okay, so long short term memory, this layer only I'm adding, and here I am going with 128 as the node size, number of nodes. Input shape, so input shape I'm taking as input shape is equal to here I'll put train underscore x. Yeah, so we named it as train underscore x only, right? So shape, and so here 1 colon. So starting from 1, we are taking the shape, and then this one is LSTM. Okay, this one is LSTM. Then we need to add here RETURN return sequence, as we did add in the last program as well. So return sequences, we need to make it true. So we have added one layer, and I think we had named it as X train. So X underscore TRAIN train. So that was the name I think we had given. Mm-mm-mm. Okay, so in this program we did not give the names to the to data, right? So what we will do is, just a second. So we had used here. Let me just add that piece of code here. Yes. So train train underscore x and train train underscore y. Okay, and we will pass pre-process. So where is that function? Pre-process df. Yeah, this is the function pre-process df, and here main underscore df we had to pass. So let me run this. Cannot unpack non-iterable none-type object. So it was accepting a. mm, hmm. So we had. Where is that function? Just a second, let me just find it out. Pre-process. Where is that pre-process function? Process pre-process underscore df. So it was accepting. Yeah, this function was accepting a data frame, right? So, and after that, I'm expecting from the that particular function. Yeah, I'll have to modify this function. I'll have to reorganize this particular function, and that I have to do with yeah, it's dropping, and this much is fine. Drop NA is also fine. Okay, this much is fine. It needs to return two things. So in bits and pieces, I have written that part, so that I have not added over here. Okay, that I have not added here in this particular function. So I'll have to add. So sequential data dot append. Yeah, this part. Previous days, and yeah, so shuffle also. So let me add this. I'm adding this in the function itself. I have added this in the function. Okay, fine. And then after that, fine. This much is done. I will also have to create lists. So here one will be bias, and bias is equal to. So this list will have all the bias sequences, and cells is equal to, again, empty list I'm creating, and for seq, okay, target in sequentil sequential underscore data. Yeah, sequential data. Then this we did not do this, huh? So here, if target is equal to 0, if target is equal to 0, then we will do cells cells dot append, and here we will have um, let me just quickly do this. So here we will have sequence and target appended. So sequence and target, these two things we will append. Okay, and then elif target is equal to 1. So else target is 1, then we will have bus bias dot append append, and here we will add that seq sequence and target target. Okay, these two things we are appending. Okay, and now this much is done. Then next part is random dot shu shuffle random dot shuffle bus bias, and similar way random dot shu ffle shuffle, and here SCLS cells. Okay, we are shuffling them, and then uh, hmm, this much is done. Let's just check LOWER lower is equal to MIN minimum of LEN length of BUYS bias and LEN length of SELS cells. Okay, so what is shorter in length? That will be coming under lower. Okay, and then we will have BUYS bias is equal to BUYS bias, and here LOWER lower we are. Okay, and SELS cells is equal to SELS cells, and here we will have LOWER lower. Okay, so then now we have SEQUEN sequential data. So sequential data finally we have is BUYS bias and cells. So both the data, okay, bias and cells, both the data will come under sequential data, and this also we will do RAN random dot SHU FFLE shuffle, and here we'll pass SEQUEN sequential data. Okay, so fine. So I'll just do this much, and if it works well, it's fine. Otherwise, we'll close. Okay, because we are already running short of time. So sequential data I have taken out, and let me just take x value and a y, and here for SEQ and TARGT target in SEQUENTIL sequential underscore data. Okay, so x dot append append, and here SEQ. So sequence we are putting in x, and y dot append append. Here we'll append the target. So we are just taking the data as x and y, and after that I'll just return 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 here np dot array array, and x I'll pass into that, and y as it is I'll return. Okay, so these two things I have returned over here. I hope I'm good till this point. Okay, so we were working here. Okay, great. So it's working. We'll get train x and train y. Okay, we have got, that's great. So train x and train y we have got, and here train train underscore x I'm passing. Okay, while adding I'm passing train x. Great. So I hope it should work now. LSTM one layer I have added. Okay, so I'll just add only few layers, not many. I'll just add one LSTM I have added. So actually multiple I needed to add, but I'll just add a model dot add. Second one I want to add dropout layer. So drop dropout layer, so that the program gets completed at least. So dropout I'll keep 0.22% dropout, and then I'll use batch normalization, so that it normalizes the activation outputs, and model dot add add, and here batch batch normalization I'll add, and nothing it'll do. Yeah. So now basically I will just add one dense layer. Okay, MODL. So although I wanted to add furthermore one more set of LSTM dropout and batch normal, but I'm not adding them. I'm just adding dot uh, dot add. I'm adding a dense layer over here. Okay, dense layer, and into this dense layer 32 I'm taking as cells, number of nodes, and activation I'm taking as ReLU. And after this I need to add one more dropout. So model.drop dropout, model.add, and here dropout, and 0 point I'll keep it as 2 only. And then final one, add again a dense layer, DENSE dense, and in this particular case only two outputs are there, so two nodes. And activation I'm taking as softmax, FSOFT MAX softmax I'm taking as activation. Okay, and OPT MIZER optimizer is equal to we have tf.keras keras dot OPTI optimizers, and so here tf.keras.optimizers.adam adam optimizer we are using. LR learning rate I'll be using very low, 0.001, and then it gave me an a warning. Let it give a warning. So DK I'll be taking it as uh, DK. Yeah, DK I'm taking as 1 e raised to minus 6. Okay, this is optimizer, and I just need to compile now, and model dot com. So it is done. Okay, so compile, and here we are passing loss function, and loss we have is the sparse categorical C cross ENTROPY entropy. So sparse categorical cross entropy I'm passing over here, and then I will be using OPTIMIZER optimizer. Okay, I have named it as optimizer only. So ZER optimizer is equal to OPTIMIZER optimizer, and then METRICS metrics I'll put as accuracy, ACCURACY accuracy metrics, and let me run this. Okay, optimizer not defined, optimizer. Okay, so that has become actually optimizer, which is fine with us. And here you can see that yeah, so it got compiled also. Okay, it got compiled as well, and mm, then model.fit fit. So here train train underscore x, and train train underscore y, and batch batch underscore size is equal to batch batch underscore size id size, and then epochs. Okay, epochs. Yeah, so epochs is equal to epochs. I've given then the same name, and then um, validation data I'm not basically using. That's it. I'm just running it with this one. Some problem. Fail to find adapter can handle input. Okay. So train Y, I'll have to check the express target. Yeah. So I'll have to look into the data type of it. Okay. So what I'll do in binary also it needs no. So target underscore Y, and it says that sorry, train Y I need to put train. So fail to find data adapter that can handle numpy.nd array containing values of types float 64. Okay, fine. So this final thing, I'll just look into the data types, that how to transform it, and check that how it can get handled over here. Okay, so otherwise I basically try to complete that how all the pre-processing should be done. And as a demo, I have shown you adding a few layers. Okay, as I said, I wanted to add more layers here. okay, in order to make the model having more hidden layers, and it could have better learning. So here we are stopping because you already have a schedule now. So we are stopping here and we'll continue tomorrow further. Okay, so I'll just revisit this particular piece of code and conclude this tomorrow, maybe in a couple of minutes, and then we will work further. All right, yeah. Thank you.
Thank
Let's
you very much, sir.